gear, full power. Hello everyone and welcome back to the channel. This week I thought I'd do something a little bit different. If you've been following along on my socials, all the links are in the description below, by the way, you would have known that I've been working on a few little side projects lately involving 3D printing and things like that. And that's sort of morphed into what we're looking at here in front of us. So I thought I'd just use this week to basically do a quick showcase of where I'm up to with all of this. And maybe get your guys' thoughts as well, if any, on what I'm doing, and if you've got any suggestions and any comments in general as well. So just give you a little bit of background on this. You know that on my channel I do cover RC vehicles, and I've been doing a lot of the Tamiya CC01, CC02 vehicles lately, as well as the Humvee, the HG Hengguan P408 as well. But lately I've been finding myself wanting to see if I can actually create my own RC vehicle. And I know that's a huge undertaking, and this might be the only video I ever make about this thing, who knows. But I just thought I'd get this out there, because what I've seen so far, what I've managed to achieve, I think, at least in my own mind, is pretty cool. And you might agree with that, you might not, but yeah, I'm just pursuing this for the moment, and we'll roll with it and see where it takes us. Now, I thought I'd do a slightly different format of video today, and so what I'm going to do is I'm going to show you just what we're looking at here in just a second and what it's all about. So having acquired this 3D printer lately, I thought I'd try my hand again at 3D modeling, and I have actually been 3D modeling in the past, long time ago, for games and things like that, making mods and whatnot. All that sort of stopped in recent times, but having picked up Autodesk Fusion 360 on a personal license, as what we're looking at here, I decided I'd give it a little bit of a go and just see what it's all about, and just see what I can do from a 3D printing standpoint, and start to design little bits and pieces. Originally, what I wanted to do with the 3D printer was to design a well, I guess the main reason for actually buying it was to design some shock mounts, shock absorber mounts for my Overland RC vehicle, Overland 4x4 Mercedes-Benz. That actually hasn't happened yet, and I find myself sort of just morphed into this whole project, little mini project that's sort of just outgrown itself now. So without much further ado, let's get into this and see just what I'm talking about here, and try and put a little bit of weight behind it. So this video is going to be two parts. Basically, I'm going to show you what I've done in Fusion 360 so far, and then we're going to move to basically the second section of the video, which is showing you what I've printed out so far and putting these concepts into reality and seeing what I've achieved so far. And just I'm actually quite chuffed with what I've been able to achieve so far. Let's just put it that way, with this software and both the 3D printer as well. So the 3D printer I'm using is a Creality Ender 3 version 2, which I've only just picked up, and so far it's been printing very well for me. I haven't done any mods to it so far, no upgrades or anything like that, so really happy with the way it's turned out. Anyway, let's go back to Fusion 360 now and just have a look at what we've got in front of us. So this is what I started at sort of doing, and obviously the comment section is always open below if anyone wants to make a comment on what they're seeing so far. This is a motor mount that I've designed in Fusion 360, and from here it's kind of morphed into, well, a little bit more than that as well. It's turned into like a gear reduction section for a vehicle, basically. So I'm just going to go through this real quick and show you what we've got. So I started off with this motor mount base, and then I mounted a motor onto it, and then from there I decided, well, let's see if we can take this a little bit further, and I started experimenting with gears in Fusion 360, and from there it just went crazy. So let's have a look at this in a little bit more detail here. So what we've got here is the motor mount itself, and we can see here that I've got the braces for the motor mount. I've got the screw holes to actually mount the motor as well. All of this was modeled by yours truly. We've got the gear here as well, the spur gear. So basically what we've got is, let's just attach the motor. So the motor attaches like that, and then basically we've got the pinion gear as well, which goes on like that. Now, at this point, I actually decided to print this out just as a proof of concept to see what was possible. And that's where obviously I did actually try that out, and I was like, hey, this actually works quite well. The PLA plus plastic which I print with actually looks very good, and is very strong as well. There's a little bit of flex to it, but if you design in the appropriate amount of braces and whatnot, you'll find that it's actually a very strong sort of material to print with. So PLA plus, definitely recommend that. Alright, so back to the design here. So I had this motor mount sort of design in my head. I was thinking, okay, well, let's see if we can take this thing a little bit further. So from there, I added a gear reduction, basically. So I printed all of this out as well, and it printed out pretty much onto the dot. The measurements were pretty much about 0.2 mil off, so I had to sort of oversize slightly in Fusion 360 to deal with that, but no big deal apart from that. So this is the gear reduction unit which I've basically got designed at the moment, and I've actually printed all of this out, and you'll be able to see this running in this video as well. So basically I've got a bit of a, you'll see there that there's a square section milled out in these gears, and then that's where this square shaft basically goes in. And that's allowed me to print these gears off separately and then sort of join them together as one assembly. And then you've got this larger reduction gear here, which I'll put some supports in, which you can see as well. And then basically this whole thing is supported by ball bearings as well. Now these shafts are a different diameter as well to basically handle the additional torque as we move through this gear reduction. So this is all very much conceptual, I must say. So I'm just trying this along with you guys as well. I'm looking at this going, okay, well, is this going to work? And so far from what I've seen, and you'll be able to see this in the next segment of this video as well, where we actually do the running process. I'll do a bit of a teardown on the actual real parts that I've printed as well, and you'll be able to see how they sort of fit together. But yeah, this thing's able to handle some serious torque right now. So I set all of the gear mesh in Fusion 360 ahead of time, and basically just printed everything out. So I'll show the gear cover which goes on, and then I've sized these appropriately for the different size bearings as well. Now I did print out a bearing test plate, which allowed me to sort of, I guess you could say, to dial in the dimensions on the bearings in Fusion 360, so that I get the ball the right size, because you don't obviously want these balls to be too small or too big. You just want a nice press fit to happen for the bearings. So managed to do that, and then the first pass I printed this gear cover out. I was amazed. I've actually got a nice fit on these bearings. They fit really nice, and then yeah, basically it's all gone to plan. So I designed everything here. You can see the rear base. I put this section in, and you'll be able to see the 3D printed version of this very shortly as well, how it pretty much enacts and depicts this design right down to the T basically. So it's basically taken shape, and I've got this rear support unit here which will house another bearing, just to give this output shaft a little bit more strength. And then you can see I've milled a hole into the output shaft, which will accept the pin, and basically from there I've got a uni joint flange as well, which goes on, which also has a hole, and that pin will go through it, and you'll see all this in just a moment as well when we go into the real section of this video, and I'll be showing you this on the workbench as well. So this is basically how it looks in Fusion 3D. You can see that the tolerances, I've been a little bit, I've given quite a bit of tolerance for movement here, quite a bit of gap to allow for play and whatnot, because that's what you want as well. Doesn't matter if you've got a little bit of play. This is still conceptual, so I'm not looking for, say, a Tamiya grade sort of RC vehicle here, but obviously, something that does work and does hold itself together and doesn't break down, all that sort of thing. So that's basically where we're at with this. So once we put the gear cover on, you'll see how it looks. So let's just step into this is the part of the design which I haven't gone too much further on, unfortunately, at this point in time. One thing I forgot to show you actually just real quick is I set up a sort of captive nut design on this on the gear cover. So I've modeled in these captive nut holes, I guess you could say, and you'll see how all of this goes together in real in just a moment as well in the next segment of this video. So these captive nut holes, yeah, they're basically designed to house a nut. That's where the term captive nut comes from. And then once the gear cover sort of goes on top, you can see how there's holes that go all the way through, and the screws will go through and capture those nuts on the other end and then bolt this whole thing together basically. So that's how that works, just quickly. So coming back to the sachet which I just started talking about, this is the frame which I've got at the moment, and this is basically the design that I've got. Now this is still all very conceptual. I'll probably make this video and I might not touch this for a little while, but I just thought I'd get this out there just to show everyone what is capable, what is possible, sorry, with Fusion 360 and a 3D printer basically. I've spent a lot of late nights working on this, mind you, but yeah, I'm really surprised and really kind of blown away with how far I've gotten so far. So anyway, this is the sachet design that I've got at the moment, and so it's going to be a rear mounted sort of engine or motor in this RC vehicle. And so that's basically how it's going to sit, and then obviously I've got the actual design here as well, and you can see here it's based loosely off the A7V German tank concept as well. So you can see here that put the sensor section in there, and it looks more or less like an A7V, not entirely like one, I guess you could say. It's not meant to, it's meant to be a conceptual RC car basically. And yeah, I've started rounding off some of the sections. You can see how the motor and the sachet sort of fits in, but there's still a lot of work to go. Obviously haven't done the running gear. What I'm thinking of doing is having like a bevel drive, like a H drive sort of setup for this vehicle. So if you're not familiar with that, I've just got something on the screen now. You can see how from the top view, the engine drives the differential, and then from there, there's a whole bunch of bevel drives basically. So it ends up being like a part-time forward drive system where the center differential is locked. It's basically a lot better than that though, because it means that on any given side of the vehicle, if one wheel loses traction, the other wheel will always continue to drive, kind of thing. So yeah, it's kind of hard to explain, but it's quite a sturdy forward drive system. It's used in quite a few sort of forward drive military vehicles, and this is the Ferret vehicle that I just had on the screen there. So yeah, that's the forward drive unit that I'm envisaging for this vehicle. So I'm envisaging a I guess you could say a rear mounted engine. Obviously got a sound unit hopefully up top here as well that's going to be blasting through these vents. So yeah, got the centrally mounted sort of gearbox, and then a differential unit, and then the out drives for the H drive as well. So that's obviously yet to be designed and modeled, but that's where I'm at with this sort of thing at this point in time. So yeah, hopefully you've enjoyed that little overview. Everything going well. This is actually how it's going to look once it's all printed out as well. Obviously you're going to have the wheels here as well, the suspension and all that sort of stuff. Haven't even decided on how the suspension is going to look, or how the sachet is even connected to the frame, to the body I mean, and all that kind of stuff. But just to give you a fairer idea of the dimensions we're looking at, it's about 460 millimeters long. So this is going to be quite a large vehicle once it's 3D printed. And yes, I do hope to 3D print this out and make this my RC project basically in 2022. So this is going to be quite a big thing hopefully on the channel going forward. Maybe I will obviously keep the games and things going as well, but just thought I'd give you guys a bit of an overview as to what's been consuming a lot of my time lately as well. So hopefully you've enjoyed this. What we'll do now is we'll cut to the workbench, and then I'll show you how this whole motor mount and the gear concept sort of goes together. I've printed out basically all the parts that you're seeing right here on the screen right now, so you'll be able to see how all this is running. I just need to print out this section for the uni joint, but I'll print that out as well, and I'll have it running by the end of this video. So let's go ahead and head over to the workbench. Okay, so here we are at the workbench. I thought I'd do a slightly different format in this video, as I mentioned before. So a little bit live here. It's probably a lot easier than trying to explain everything in a screenshot format with captions and whatnot. I'll be showing you a whole bunch of captions. So this is basically it. We've got the motor here. This is a standard Tamiya 540 SH motor that you'll find in a lot of the 110 scale electric Tamiya kits. It's a 27 turn, I believe, and it's got a fairly sort of decent amount of torque. It does rev quite high. So for this application, where I'm going to design a A7V or a wheeled version of an A7V tank, basically an armored car, we basically need to gear down this motor quite a bit, and this is what this unit is here, obviously. So we've had a look at this in Fusion 3D already, so I don't really need to yammer on too much more about why this reduction unit needs to be. This is basically showing what the printed version looks like. So obviously I've got it all assembled here. I put this together about a few days ago, and I've used a few washes here and there in the assembly of it. Now you can see here that something's happened in the 3D print of the top part of this gear cover. Unfortunately, that was a little bit beyond my control, but this is a prototype part, or these are all prototype parts anyway. So the whole point of this exercise is to prove the concept, and just prove that we have here a working and functional system that we can then continue to design the frame and the body of this vehicle around, and hopefully have ourselves a nice RC armored vehicle, completely built from scratch, and yeah, it's basically showing off that the ability that 3D printers can give you to actually design RC vehicles. Anyway, I've got the motor hooked up to the electronics here. So this is the venerable quick run waterproof 80 amp, so it's the 1080, the quick run 1080 ESC. I'm just trying to get that in focus here. I really can't get enough of these things, as you've probably seen on some of my social media. I've snapped up quite a few of them now. I've got about 4 in total, so this is the third one here. So this is going into this project basically. So anyway, enough yammering on. What I might do actually is I'm just going to pull this thing apart and just show you guys what it looks like inside. You can see the fit and the finish of it. I'm really happy with, and this thing is really sturdy as well. Like, it's really, here if you push the motor down a little bit, there is a little bit of flex, but it doesn't affect the gear mesh or anything like that. And you can see just through there, you can see one of the ball bearings there. There's a total of 1, 2, 3, 4, 5 ball bearings, sorry, 4 ball bearings. So there's one back here, there's one here, there's 2 up here, so that's 4 ball bearings, and then obviously here you've got the motor pinion behind here. So anyway, let's go ahead and get this gear cover out, and we'll go ahead and just have a look at how this thing looks in real life, shall we? So I'm just going to take this apart here. I'm just going to speed the video up. Okay, so here we go. We've got the main 4 bolts, I guess you could say, off. And so you would have seen this in Fusion 3D as well, how I had sort of designed this as a separate part. So now this outer support, rear support as I call it, can now come off. And I've designed these parts with a fair bit of tolerance, but hopefully enough that it still gives a decent sort of press fit. So you can see here that this bearing is kind of press fit into here as well, and you can see that the 3D printer has printed out the flat sections on this output. Just trying to get that into the camera there. You can see that. So once the bearing goes in here, it's obviously full circle here for about 4 mil or so, and then from about 4 mil onwards on the depth of this thing, then you've got those flat spots. So basically that just means that this bearing cannot be pressed in any further, which is perfect, exactly what we want. So that worked out really well. I must say, all these parts here, they're pretty much first print. So first print, and then it went together, and the gear mesh is all perfect. I was so actually I was really chuffed about that actually. So Anyway, let's pull this apart. You can see here that even the fit of this thing is basically flush fit, and I did not have to actually sort of design any tolerance or any extra oversize on this gear cover itself. In order to make this fit, it just fit flush right off the printer. So with the settings in Fusion. Alright, so here we go. Now I've actually I've lubricated this with some Tamiya grease anyway, during the process of kind of installing everything earlier. And so this is how obviously the gears sort of fit together. You can see that there. You can see some of the grease is being pushed aside. Now I do use washers in here. I'm just trying to get a bit of focus on that rear gear up top there. So yeah, I've put some holes obviously in that gear just to give it a tiny bit of, it's basically just a good design practice. Lightweight a little bit. You don't want to really add any flex to these parts, but it saves on plastic as well, I guess. And the other thing as well is it also helps to make the gear easier to remove off the build plate as well. So that's another thing, because sometimes these gears can really stick onto the 3D printed build plate. Anyway, so this is obviously what you've already seen in Fusion 3D in real now. So you've got the pinion here, which I've printed out. Now with this pinion as well, we'll just start off at the pinion, I guess. If you look real closely there, you'll see that I've actually put a set screw, or like a grub screw, into there. So that was modeled into the pinion. It got printed out that way, and then I gently threaded that through manually by just, basically screwing that in with an Allen key. So once it hits the center shaft portion, I just gently give it a slight nip. But you don't want to obviously tighten it too much, because the threads on the gear obviously are plastic, the PLA plus, so you don't want to strip those out, which the metal grub screw will easily do if you over tighten it. Alright, so on the front here we've got some, obviously you would have seen these in Fusion 3D anyway, but we've got the motor mount holes, and then I've just driven through these M3 metric Allen bolts through. Allen screws, and then I've got washers behind. So the design of these holes in the motor mount allow the motor to be moved up and down and left and right just a little bit in order to get the mesh just right. And you might be wondering, well, how on earth do you actually get the mesh right on this thing? Because once you try and put everything together, you can't see anything anymore. Well, that is done by basically just pull out the lower section of the gears. Whoops, and I'm really going to town on this right now. And you'll see here that you can actually put this in like so. It just fits through, and then into the bottom section of the gear. And you can see here that now we've got perfect adjustability. Well, we've got a perfect vision into the actual gear mesh, and we can see just if the gears are meshed or not. Now I'm not going to take this all the way apart because I've kind of got it set up real nice, but these two gears pull apart as well. And there's that hex, or not a hex, but that square shaft that you would have seen in the Fusion 3D inside there. So that that square shaft basically presses into this gear and this gear, and allows this to function as one unit. Because basically it's going to be rather impossible to print these two gears like this, exactly how they are now, without adding a lot of additional support plastic material, which is not great. So anyway, that's how that works. Now I do encourage obviously the use of washers here. So normally I just put one washer here. One thing I will probably do is I will reprint this particular gear here, because I've extended the length of this shaft portion here a little bit since I've designed it, because I find that it's just a little bit sort of too short to fully go into that bearing. But that's fine, it'll do the job for now. So let's just go ahead and put this back together. So you can see there that just goes in there, and then what we do is we just get, just focus on this a little bit better, get this washer like this, and then just put this washer on like that. Okay, now basically I've already done the same thing for this gear up here, And in well, a little bit later on in the video, what I'm going to do is I'm going to show you once I print out that flange portion for the universal joint. I'll put that on and then we'll give this thing a good run and just see how it works. But you can see here, hopefully you can kind of see that I've got some washers in there already, and that kind of helps just so that when the gear, if the gear ever does come hard up against the bearing, it doesn't actually rub as such. But the way I'm going to obviously set this up is that it's hopefully not going to rub anyway as it runs. And you can see there it's pretty smooth, but we obviously haven't got this rear portion on either, so that's why you've got quite a bit of slop here. Anyway, alright, so we've got this gear up here, it's ready to go. So basically just put this through like this. And what you're looking for is basically this shaft portion here needs to go into this bearing here, and then obviously it's going to come through on that side. So it's just going to take a little bit of coercion, I guess. Just hopefully we can get this right. There we go. That's actually gone on a lot easier than I thought. And you can see already this thing should be screwed in properly before we start trying to turn it. But you can see there already that the mesh is just fine. Because they're spur gears as well, they are going to sound a little bit rough, but once we get this all bolted in again, it's going to be just fine. So that's basically how it all goes together. And yeah, so that's how that works. So when we bolt this thing back up, I'll go ahead and run it for you. I've got obviously the battery and everything here, and you'll be able to see just how much torque this thing can exert without slippage or anything like that. The gear mesh is just absolutely fantastic. So I think what I'll do is I'll pause the video here. I'll go ahead and start printing out that flange portion that we saw in Fusion 3D just before, and then we'll hop back here, and then I'll obviously I'll put all this back together. There's no point putting it back together now and then trying to put the flange on, because the flange is going to be a press fit on this shaft. So I'm going to need to have this pulled apart so I can basically put some pressure on this gear and then force the flange on. So yeah, anyway, this was just a little bit of an exercise to show you how this thing looks inside, and you can see here that how the gears mesh and everything like that. But yeah, just to sort of summarize for now before we end the video with a bit of a running, is that this PLA Plus is really good material for 3D printing, and these are all prototypical parts as well. So I've really got a bit of confidence in this actually, and maybe not too high hopes, but I've got some positivity here that this thing will be able to take the load of the RC vehicle that will eventually end up wrapping itself around this thing. So this is just the initial gear reduction obviously, and after this it's going to obviously feed into a universal joint, a shaft, another joint, and then obviously the gearbox and final drive, and then out to the wheels from there. So obviously all that sort of stuff hasn't been designed yet, but this was just proof of concept anyway. So let me go and print out that universal joint flange, and so we'll just press fit that on, get this thing all buttoned back up, and eliminate this sort of shaft play here once we get that universal flange on as well. And then I'll go ahead and fire this thing up and we'll see how it looks. Okay, so we're back. So everything's put back together now. It's all buttoned back up again. You'll see that it's still got that same flush fit from before. Really happy with the way this thing has turned out, I must say. If I haven't said it before already, it's really exceeded all of my expectations. You can see here that the play here is just right. It's not too much, but obviously it's good to have a little bit of play in these things. You don't want this thing to be too buttoned up, too tight. Now obviously we've got the half of the universal joint here. So what I'm going to do now is I'm just going to get it all set up. I'm going to turn it on, and we're going to give it a little bit of a run and just see. I'm just going to demonstrate to you how powerful this thing is with this motor as well, this gear reduction unit, and just how strong it is as well. So we won't have any of that end play. It's just right, it's just set up nicely. So I'll go ahead and get that going now. Okay, so I've got all the electronics connected now. I've got my ESC, got the on-off button here for the radio. So basically I've got the transmitter on already. Let's go ahead and turn on the receiver. Okay, so here's the moment of truth. So basically got all of this set up. I've got the transmitter just slightly out of view here, and I'm just going to go ahead and just give it a slight amount of power and just see how this thing goes. You can see here already that now I've set this ESC up, this quick run, to be only about 25% full throttle. So, or is it 50%, one of those. So even if I give this thing full throttle, it's only about 50% power. So I'm doing this just to slow the vehicle down as well and make it run a little bit more realistic. Obviously this is just me really just slightly squeezing on this trigger. You can see here that there's a slight bit of out of round, well, just a little bit of wobble in this flange. It's not a huge deal, can probably sort that out. But the whole purposes of having this universal joint anyway is to sort of sort out all that issue. So it's running good so far. It's got grease in there already, so from last time when I greased it up. So let's give it a little bit more power and just see what this thing can do. About halfway now. There we go, full power. Okay, so I've actually turned the drag brake off on this as well. So when you get off the gas, it actually nice and smoothly stops. So I'll probably have that running in the vehicle as well when I eventually build this thing. So yeah, that's basically it. So now let's give it a little bit of a torture test and just see. This is all prototype parts anyway, and just see how strong this thing is. So obviously just bear in mind the ESC is set to 50% full power at the moment, so not 100. But I'm just going to hold down the flange and give it a little bit of power, and you can see it's really eating into my fingers, but it's not, the gears are not slipping or anything like that. Let's really clamp down and give it 100%. Oh, let's try that again. 100%. Oh, okay. You can see there it's actually quite strong, so it actually wants to turn the case as well. So that's how strong this thing is. So really happy with the way this thing has turned out, I must say. So I think this thing is fit for purpose from what I'm seeing here. Let me know in the comments below what you think as well, if there's anything you think I should be doing. I know that this flange is a little bit oversized, but hey, I want this to serve as a bit of a flywheel as well, I guess. I was actually going to make this a lot rounder as well, a lot sort of bigger in diameter, and then maybe attach some weights around the edges as well. I don't know, I may still do that, but I've pressed this thing on now, so good luck trying to get this back off the shaft again, I guess. So hopefully, yeah, this universal joint works out, because I haven't printed the other half of it yet. And I haven't even designed the center connector yet for the universal joint. So hopefully once I design, you'll see here that, you won't be able to see actually, but I've got an idea to basically put 2 screws into these holes, and then you'll have the connector, which is like a connection block in the middle, and then another one of these flanges rotated 90 degrees basically, I think 90 degrees, and then brought in on this side, and that will be the universal joint complete. Then it's going to go out to a shaft, and then into the gearbox, and then into the differential from there. So this is the initial gear reduction unit, and you can see here it's running very well right now. So really happy with this. You can see that as well. So you would have seen a bit of a sneak peek on this on my Instagram if you had been sort of following my socials lately. So this is, yeah, basically the final, well, not the final, but the production prototype, I guess you could say, and this thing's going to make it into the vehicle, hopefully. So next thing to do is basically set up the chassis, basically the frames, the frame rails, print those out, put this thing on, bolt it on. I've got the bolt holes already set up as well. You would have seen in Fusion 3D, so I've got to get the sachet all sorted out. The suspension needs to be designed, the differential, the gearbox as well, probably be a single speed gearbox. The out drives, the CVs, the bevel drives, all that sort of stuff is still yet to be done. So yeah, fun times ahead. It's going to be a lot of work for sure, but this was more just a proof of concept to see that this 3D printing actually works and is actually fit for purpose. And I think you'd agree that there's a lot of torque here, and there's a lot of force that is carried into this motor. And yeah, I can even bump up the ESC a little bit higher to 75% or even 100 if I want more power from it. And I'm confident that the gearbox will be able to stand that amount of power as well. So very, very happy with this right now. And yeah, so thanks for watching. Please leave a comment below. Please like, comment, subscribe if you haven't already, if you want to see just how this thing sort of develops in the future. If you're interested in this, I just thought I'd give this a quick little showcase today as part of this video. So I hope you enjoyed this. It's a little bit of a different format this time. And until next time, I'll see you in the next video.